about to start. Any questions about anything before we start though? Questions.
Just need you to check the questions for the.
This for homework?
No. Just need you
Oh. For the lab answers?
for the homework.
Yeah, for homework, yeah, we're gonna do that after like the lab time. Questions about anything before we start? Boom. So today's lecture is gonna be on more control structures, which we know is if, else if, and else. This controls our program. And then functions. We've been using them. Functions like substring, length, at. All of these are functions that have been given to us. Before our lab, we're going to have to create our own function and use other functions that have been provided. So I'm going to go over the objectives. I'm going to go back into logical operators. Now I'm going to go into how we're going to use functions in our lab and how we kind of want to think about them going into the lab. So the objectives. The first objective is using control structures. We're going to use more if, more else if, and more else. Second is we're going to use our logical operators in case we need two or more conditions to be true in order for us to proceed and do something specific in our code. And then lastly, we're going to be calling functions. So your lab, it'll be a combination of all this stuff. So make sure you're getting it. So logical operators. We know we have three. The first is the AND operator. AND is used to say, I need this thing to be true, and this thing, and this thing, and this thing. All of these things have to be true together for the overall condition to be true. All conditions have to be true for the overall condition to be true. Secondly, we have OR. OR means what?
Only one.
Only one.
Those straight bars or are those like a...
Yeah, the straight line. The straight line. So, or, like Caleb said, my bad, ACE, only one condition needs to be true. So if I have a myriad conditions and only one is true, they all true. The overall condition becomes true. And lastly, we have not. Not just turns true into false and false into true. So if I have some condition, let's say 3 is greater than 2, we know that to be what? 3 is greater than 2, is that true or false? True. If I throw not in front of it, it becomes false. Likewise, if the original condition was false, if I throw not in front of it, it becomes true. And I'm going to show examples of all of these and kind of how you want to think about them in terms of your lab today. Questions on the operators? Cool. So going back to the template, right? We know for if and else, we always need the keyword if, then our parentheses, your curly braces, and your else. Inside of the if is where we put our condition. Our condition always has to evaluate to either true or false. Only two options. We can have as many conditions as we want, and we need to separate them with an operator, either and or. We either need both conditions to be true, or one of the conditions to be true. For and, we would throw both of the and symbols in there. And this means condition A needs to be true and condition B needs to be true in order for us to do what's inside of the if statement. Both conditions have to be true. So let's take these two conditions as examples. So this is going to be considered our first condition. This is our first condition. And I left this space here so you can kind of understand that there's going to be a whole nother condition on this side. So our first condition is a compound condition. I have 2 equals 2. Is that true or false?
True.
True. 2 is equal to 2. And 4 is less than 3, which is what? False. So the result of this expression would be what? False. Because both of these will need to be true in order for the overall expression to be true. So on this side, we know we have a false so far. we still have to evaluate what's going to come later, because if this were to be an or, all we need is one of the like bigger conditions to be true. But because we have an and we know we already had a false here, there's no real need to look at the second condition, because no matter what it is, the overall condition is already proven to be false. So going back, we already know that this condition evaluated to false. It already evaluated to false. So we throw an and in there. It doesn't matter what comes after. It could be 1,000 true statements. It doesn't matter because one of them was false. So the result of this expression is what? True or false? I heard one false. Anybody agree with false? Anybody think it's true? True, false, true, false, false. Okay. False. It's false because this entire expression evaluated to false. So I was left with a false and a true. This is a bigger false because it was, in order to arrive at that false, I had to look at the two sub-conditions. So this whole thing evaluated to false. So I had false and true, which we know with and gives us false. So let's say I have this situation here and I'm going to code it out. I'm going to have y'all help me code it out. So let's say in order to legally drive, like we went over yesterday, we know there's 3 conditions that have to be true together in order to legally drive, right? Have to have a license, have insurance, and have the registration. So I want to start with creating some variables to represent this data right here. So what type of variables could I create to store whether somebody has a license, has insurance, or has registration? Yeah, we need our variables first. We don't have any variables yet to even use.
Put a bull.
Bull.
Yeah.
Okay.
Let's call it the license.
Bull license.
Yeah. And then semicolon. Next bull insurance. Press the enter key after the word license.
I'm gonna just do it all in one line so we maximize space
Okay.
down here.
So then
What are we thinking for the last one?
registration.
That look good to everybody? As a little nit, when you naming like bull variables, so let's say this is done on line 6 of my code at the very top, and then I write 1,000 lines, I get down to line 1,006, right? If I see one of these variables used, it's not so clear to me that they're bool variables, like that they have a value of true or false. So typically what you'll see in code is something like this, has registration. Because when you look at this, you know that to answer it is true or false.
For registration, TF. Does that work?
I mean, technically it could work, but the general convention you'll see in like industry is literally just taking what was provided and just like writing it as a variable, just taking the space out. So that way when you see it, it's kind of clear that you're asking a true or false question. So cool. All right, so now if I want to check if, and let's say I already prompt the user. So I get the values from the user already. I'm not going to write the code for it right here. If y'all want to see it in ISTEM, I'll transfer it over to ISTEM. But what would the condition be in order to print out you can legally drive?
Has license equals 1, right? Is it
To
equal?
check if it's true. Everybody agree with that? Check if the value is 1.
Is it equal or just equal?
Equals. Yeah.
What's the difference in
So equals would be if I wanted to say has license equals true.
Okay.
If I want to check if has license equals true, I would say if. Boom. So I'm gonna say if has license equals true.
Wasn't it one here?
Do you put one or does true work?
Either one will work. I know it's like, dang, is it true or is it one? It's kind of both. It's kind of both. It really takes like playing around with it to understand when it's acceptable to use one and when it's like if you try to print. If I literally did C out true, it'll print one instead of true. Why that happens, I couldn't even begin to explain. That's just how C++ is. So if has license equals, I think you can actually write it like this. This should be fine. So if has license equals true. And. And why do we need and right here?
Because it has to meet all the conditions.
Has to meet all the conditions. We need all of these conditions to be true in order for us to tell the user that they can legally drive. So what comes after and?
Has insurance.
Okay.
And has registration.
Okay. And what now?
You can see out.
And so one thing, I'm gonna write it on a separate line. Another way I could have written this if statement is just if has license, if has insurance, and if has registration. C++ already knows when it sees a variable to check if it's true. Because when it sees that this is a bool, it already thinks, let me check if this variable is true. Yeah, so instead of writing this out, like this is perfectly fine. You won't see it in industry, but this is acceptable. I'll accept it. The real way you want to, because if you read this as English, right, it'll say if has license and has insurance and has registration. It just flows a lot better. Like you want to try to get your code to look as close to English sentences as possible, yeah. So somebody else reading your code can follow without needing you right there to explain your code. So I'm gonna leave that one up there. Anybody want to see it and ask them to prove that it works and like test it? All right, cool. So I'm a, huh?
How did you just indent all of
Oh,
that?
so I copy everything and then I press tab.
I thought it was delete all and make a tab.
Yeah, I ran into that a few times. I think it depends on like what machine you on.
Okay.
So let's see. I got to prompt the user. I'm a comment. This is public on AirStem, by the way. Like you can go in and see this workspace. It's called bool condition. So if you go to the top tab, it's workspaces, and it'll be a folder called public. And in public, you should see bool conditions, and then you can join. And so I'm gonna say, create some variables. Next, I'm gonna prompt the user. I'm gonna say, do you have license, insurance, and registration? And so I'm gonna CN all of these in one line. So I'm expecting the user to enter 0, 1, 1, or 1, 0, 1, some combination of zeros and ones.
Bool, like that entire line 8, that would work?
Yeah.
You don't have to put it.
Nah, so if all of the variables you creating are of the same type, you can just write.
I didn't know that.
Yeah.
That's what happened.
It's you don't. I mean, the reason why I'm not gonna teach this up front is because then you'll think just because all of these are of the same data type to make a long line. It's only when these three are like or these are related and it makes sense to do it.
Okay.
You don't want to make
First
a.
name, last name.
Yeah, exactly. First name, last name, it would be appropriate. But if you got so many unrelated things, and just because they're the same data type, you try to group them, yeah, it's not. Yeah, people would rather you just go vertically and just,
You use commas, not semicolons?
yeah, commas to indicate something's coming after,
Okay.
and semicolon after the last one. Good questions. So I'm gonna see in all of the inputs in one line. And so what I'm gonna do here is I'm gonna make a comment so I don't compile it. But this could have also just been, like I said, the name of the variables. And so let's say else we want to print out, nah, you cannot drive. Shit. Slam. Back. All right, so we think this should work. We think this should work. So we're gonna check if all the values are true. If all of them are true, we should print out you can legally drive. Else we should print something different. So let's see. So do you have license, insurance, and registration? Remember, it's expecting me to enter a combination of zeros and ones representing true or false. You got, well, actually, it only, so if I do 0, 1, 1, then yeah. So yeah, I put a space between them, or I could have just pressed enter after each one. It doesn't matter. And so let's say I do, you want to change the numbers of words? All right, boom. Let's see. So I'm going to convert the whole idea of needing zeros and ones into a user being able to actually enter like yes or no, which is like more realistic in what you would see in the actual application. So just to show you the case of this actually working, what sequence will we have to enter to get you can legally drive? 1, 1, 1. Which means true, true, true. Hold up. I think if I do 1, hold up. Let's see what we did wrong. Why it's not trying to read? Oh man. Oh, that's why. My bad, y'all. I'm like, dang, it's only reading in one variable. All right, here we go. So if I do 1, 1, 1, you can legally drive. The error was I had commas separating these because I copy and pasted it from here. But now it read the 1 into 1 into 1. And we get you can legally drive. So the only sequence that will work is 1, 1, 1. True, true, true. We good with that? All right, now I'm going to show how we would kind of change this up so that the user can enter something like yes. Let's say we want the user's yes response to answer all of these questions, right? Let's say 1 yes means you have all of these, and 1 no means something from this list you don't have. It could be all things you're missing. It could be one thing. But we just want to make it easier for the user so they can enter yes or no, and we're going to handle it similarly. So in this case, we will only need one variable to store the yes or store the no. We just need one variable. So let's call it answer. So instead of doing cn and storing all that, we're just going to do cn answer. So this is going to ask the user the question, store the response inside a variable called answer.
So how does it apply? If it put yes, how would the code know that means 0 or 1?
Right. So I'm about to show you. Oh man, what just happened? All right. So we're going to have our if statement. It's going to say, what? Oh, comment everything? Right, I be doing stuff not really real. Alright, so my bad. So you copy everything that you want to comment on Mac. You hold Command and press the question mark button. And if I press it again, if I keep holding command and pressing it, it's just gonna keep toggling
Oh, that's cool.
to comment,
Oh,
uncomment.
it's control.
Huh?
Okay.
Hmm?
That's
When I think it's hold control and press the question mark.
It's control.
Yeah.
Wait for the Mac is control what?
Now you,
Mac is command.
yeah, hold
Oh.
command and press
I'm
the
trying
question
this
mark.
right now.
Bro, what?
Yeah, so if you wanna like comment a whole chunk of code out, you would copy the whole thing, hold command, press question mark. And if you wanna uncomment it, you do the same thing. So y'all was like commenting stuff line by line. I mean, normally you would learn multi-line comments. Multi-line comments, I can just tell it where to start and where to end, and it'll do it. But that's a little more like, I think, difficult to understand. So yeah, that way is how I normally do it. So if I want to write a statement to check the actual string, right? How would I check if the string? All right. How would I check if the string is a yes or no?
Can you do string equal and just put yes in quotation marks?
String. So this would tell us if it's a yes. If we wanted to just, let's say, you know, sometimes they let you check or enter Y or N for yes or no. We could also be like, or answer. How would we check if the first character is a Y? At what index? 0 equals Y. Or, because it could be lowercase or capital. This is like how we would cover all those cases. Yep. And let's say yes could start with a capital as well. It's like if we want to cover all the possible cases, and a lot of y'all were asking this before we like got to this topic, so I'm addressing it now. If you want to cover all the possibilities, you can say this, or this, or this, or this. Add as many as you want, so that the user has like more freedom in terms of entering something that should technically be correct. And you just say, all right, bro, if you enter something that seems right, I know what you meant. So if the user entered any of these, we want to consider that a correct answer. So what will we print out? Remember, we asking about license, insurance, and registration. If I say yes or Y, what would I want to print out? You can legally drive. And let's say I'm going to keep the same else case. Boom. So let's see if this works. So if I enter yes, what should happen? You can legally drive. So it took what I entered, even if I enter like yeah. If I enter yeah, the first case is going to fail because it's not yes. The second case is going to fail because it's not yes. We're going to get this case, and this is finally going to pass. Remember, we only need one of these to pass. So this is another practical example of when you will use or. Because we're saying the user has options in terms of what they can enter, and we still want to consider it correct. So if I enter yeah, it still knows that I can legally drive. Even if I just enter a Y, it still knows that I can legally drive. If I enter no, nah, because all of these cases failed. All of those cases failed. Make sense?
Yep.
Question?
I tried making my own workspace, just on my own, and
Mhm.
I tried just copy and pasting all of it, and it's all gray, and it's not understandable. Huh?
Oh, you probably didn't name it CPP, the file or CPP file. Good catch, because I definitely was thinking it was the code. About to say, dang. All right. So,
That shit got me the first time.
are we back to the lecture, man? So this is an example of, well, we ended up using and or, in that example, but yeah. So I think we kind of got the and or operators down. So just to kind of go through this, even though we just did it, remember or is when any condition can be true, and we want to consider the greater condition to be true. As long as one is true, we good. So an example of that is 5 divided by 2 equals 2. Is that true or false? True. We still got to see what the operator is before we can just say we can check out, right? So boom, once we see that the operator is or, C++ doesn't even look at the stuff that comes after because there's no need to. There's no need to. Once it knows that this is true and we have an or, we're good. So what would this print out? Yes. All we needed was one condition to be true. It was good that the other condition was true, but we didn't really need it to be. So let's try this example. So let's say the qualification for a specific job, right? They just want you to have at least an associate. So you can have one of many degrees. You can have more than one, or just one, or you can have no degree. But in order to get this job, you need at least an associate's degree. So how would I start writing the code for that? And I could actually just go into another workspace. I'm gonna copy the question over. So remember, the user has to have some degree in order to qualify for this job. So how would I start this off? Remember, I normally start with the variables. Bool has degree. And so how will let's assume that the user is going to enter the degree that they have or enter like none. Like they're going to actually type out the degree. The question is, let's say the question that you're asking the user is, do you, or let's say, what degree do you have, if any? Let's say this is the question. And so I'm gonna actually just do cout. So this is the question that we have to work around for this scenario. So how will do we still want to keep this variable or we need to update it? Update it to be what? Yep. Oh, my bad. Dang. It's not my language, man. My bad. It's not my native language, man. All right, so boom. String what? What we gonna name it? Degree. You said well?
No, I was just thinking about
Oh. All right, string degree. So we create our variable, then we ask the user what degree they have. Now what do we need to do? CN degree. Okay. So let's say the user enters their degree, or they entered, I don't have a degree. Let's say enter something else. How do we start checking the input to see what they entered? If
you can't do higher or lower than because it's a string. It's not.
yeah, it's just a string. So do we want to handle this one the same as like the last case where, let's say they could enter masters, they could enter M, they could like, we want to go that route or just, all right. So degree equals what? What do we want to check the degree for at first? Associates. Or said capitalize associates. Oh yeah, you want to put it all in one? Okay. It's gonna be loaded. All right, bachelors. Or so we just gonna keep doing or.
You can separate
All right, yeah. So
You can-
that will work.
You can make several different
Yeah.
displays for all of them.
Yeah, you
Just
can
things
put
that are put on one line.
you can put multiple variables inside of the parentheses.
Yeah.
Hmm.
Oh, okay.
Yeah.
Is there a limit or is it?
Nope.
Nope.
So the way I would recommend you do it, just so it follows more of a flow, I would just start making else if statements for the other cases.
Okay. And copying the same CI statement.
Yeah, exactly. Yeah. And so I think what we could actually do is be like, so let's say it was a associates, you could say you qualify because you have an associate's. And so for the bachelor's, we could do something akin. We could say, yeah, you qualify because you have a bachelor's.
What if somebody puts down like
That's a good question. So if somebody enters that, what would we need to change to compensate for somebody entering like B.S?
Name
Associate
at
at zero,
name
Yep.
at
or
zero,
Mhm.
B,
B at zero.
Yep. So we could just check.
and capitalize that B in bachelor.
Oh, okay. My bad. So yeah, we could also say or the degree dot at 0 equals a B. Let's just say that we assume it's gonna be capital. Normally it's capitalized when they do the abbreviation. Is associates the same thing like an A? I don't think I've ever seen an associate. Okay. All right. Well, boom. And so let's say we want masters this time. I guess we could just. Huh? I don't think you can do that. Normally, like what I learned in school was that whatever they entered, we convert it to uppercase or convert it to lowercase. So that let's say, so see out here we're checking to see if degree at 0 equals a capital letter. The user could still technically enter a lowercase letter, but on our end we could say we could take whatever the first character was and just make it uppercase by default. Like we could override it. I don't know how to do it in C++. I think it's just too upper though. I think we could just do degree dot at 0 equals degree at 0, and then we do 2 upper. I think this will work. So this should be able to take the first letter. We'll take the first letter, make it uppercase, and put it back in that place.
Okay.
So it's going to take it, make it uppercase, and then put it back in the same place. So this should handle the case of if they enter something lowercase. So we don't even need well, we're checking for uppercase, right? So we don't even need this anymore. Because we're going to automatically take the lowercase and make it uppercase. So we don't need to check for lowercase anymore, technically. And so we're still checking for masters. Let's say else, we just print you do not qualify, no degree. Oh yeah, let's do PhD too. Huh?
So you spell you spell
Which word? Oh, qualify. Dang, I'm not on it today, man. All right, boom. So let's say the else if the last else if is going to be for P. I guess we can just check if it starts with a P. Yeah, some people do say doctorates. If we want to handle it like that, we could. Is it doctorates or doctorate? Doctorate. All right, boy. So if it's doctorate or if it starts with a P, then we're gonna consider it a PhD.
The H is uncapitalized.
All right, bet. Hey, man, leave me alone, man. It's like no. Y'all try to pick on me. All right, boom. So I think this should work. I mean, or if we want to also account for the case where it could just start with an A. I think we good. Let's see what errors we get. Oh man. Don't do it, bro. Don't do it, bro. All right, so we good. So let's see. What degree do you have, if any? What should we try first? P. So if I enter P, what should happen? Should be you qualify because you have a PhD. Let's say I enter masters with a lowercase m because we banking on this two upper thing working, right? So let's see if it works. Huh? I mean, I never made y'all do this, so like I ain't, you know. And that was extra credit. I ain't make you do it. If you read it and did it, you did it. I mean, I don't use this language, so like I'm not OC familiar with like, I know how to do it in different languages, so I forget sometimes. So this actually did work. We converted the lowercase m to a capital, and so this case failed because we didn't get, actually not, this case passed. But if we enter, let's say, just a lowercase m, this should still work. So basically, when I enter the lowercase m, it hit line 21. It said, does degree enter masters? No, because we only enter the lowercase m. So it fell back on this case. It said, all right, is the degree at 0 a capital M? Well, yeah, we made it a capital M on line 15. So therefore, the case passed. So this checks out. We all good. Any questions on any of this? And this is mainly using or. We're just checking a bunch of possibilities to say that the condition is true. All right, so I'm not going to write the code in here. We did it in EdStem. So now for functions, and this is going to really help you with the lab. You're going to need the part we just went over, but this is like, in my opinion, more important. So anybody want to tell me what a function is? I need a reminder. I don't remember what a function is. I saw a hand over here. I don't remember what a function is.
It's something that the computer already knows how to do that we don't have to like tell it to do, right?
In a way. He said it's something that the computer already knows how to do. We don't have to tell it what to do.
Don't you
That's-
use functions? That's your job?
I use functions, yeah.
I thought you used them.
Yep, you can make functions. So functions can exist already, or you can make them yourself. But what you about to say?
I was gonna say it's a command that you give to the program to make it do a specific thing.
That's true as well. Anybody else? Something that you call. What you mean by that? How you call it?
Like, it's code that you call with the state.
Okay.
Shazar
He said, Shazar says code that you call and you use one statement to call it and it references some other block of code. That's also true. To sum it up, a function is a set of instructions, right, to do one specific job. The three functions that we use for strings are substring, length, and diact. We didn't write any of these functions from scratch. They already existed. They already did the work for us, right? If we wanted a portion of a string, we knew substring could handle that job. So we just cheated for it. We just used substring. Somebody nice created it, and we just used it. We just used it. Yep, it came from a library. Somebody created a library with all of these functions in it, and we just use them. So somebody had to actually write the instructions for these, but not us. We just use them in our code. All of these are examples of functions. So how do we know that these are functions? I want you to take maybe 10, 15, 30 if you need it seconds. Just talk to a partner. Think about how we identify functions. What makes these stand out as functions? Yeah. Oh, it's robotic. Huh? Yeah. All right, you about to. You better be thankful you. Huh?
You can ask me the next question.
When I do that?
You know you was about to. You know you was about to. Oh. Do you see how many like I did this up? Oh, you can have that.
Oh, just from voting? All right, how we know where the function's at? Nah, you don't sound stupid. You had something stupid about it. The parentheses. I didn't do it. Huh? Huh? Yeah, that's a conditional. All right, similar. All right, boom. All right, int-main is a function. All right, so we seen this slide before, so I expect some accuracy, man. We seen this slide before, like week 2. Week 1, week 2. So what are the 3 functions being called in this code? So who thought int-main was being called in this code? It's not being called. What's being done to it?
No, it's doing specific to job. It's like.
So that's why you need to stop missing out.
Alright, look. Int-main is not being called, it's being created. So it can later be called by somebody else. In order for us to call foo has to be created somewhere. So somewhere there's something like this, but foo is here with steps for foo, so that you can call it. Same with substring. Somebody had to create substring and create diet and create length, so that you can call it like these.
Could you call like later on in the code?
Somewhere C++ does call int-main. I don't know where. That's like, this is as
So basically,
As
it's
deep-
just like a small proportion of something. Like, let's say you created a game, and then you make that, and then you could call that.
exactly.
Yeah.
Yep.
That's why.
Mhm.
Like,
Yep. And that's what your lab
you'll
is.
just call int-main and it'll do all those.
Yeah, exactly. Yep.
Didn't you say in like one of our last slides, you said that we're making many functions
Mhm.
for each one?
Mhm. Yeah. Functions. Typically, you really could write a whole bunch of code in int-main, but normally the best way to do it is extract certain pieces into their own functions, and you give the function a name so your code flows way better. Just like, I think the original example I gave was like, let's say in your code you're using CMath library and you do POW, P-O-W. By reading the name of that function, we know exactly what it's doing. It's doing power. If I were just to use symbols in like the actual math equation to do the exponent, you might read it and say, what is, like, why did this person do this? But if I use the function name, and these are like the generic names because I didn't want to like make it too obvious, but you wouldn't name it something generic like this. You would name it something very specific to tell the user what you're trying to do, what you're trying to accomplish. Just like substring, length, and diet. Like it's not super intuitive, but once you understand what those functions are, like you can kind of remember them by their name. What they do is the name. Length calculates the length. Substring gets a sub of the string. So which one of these functions, and again we've seen this slide, which one of these functions returns something and stores it in a variable?
Slope intercept. Five.
What's the function called?
Foo.
Foo.
Yeah.
Foo is the function that's being called. And based on what foo does and gives us, it stores it into this variable. Yep. So based on the left side of this equal sign, since this says slope intercept, we can infer that foo calculates the slope intercept. That's kind of how you want to look at it. Like, all right, maybe this isn't named super specific, but what is the name of the variable? How much data can I get from how this user named their code? So we can assume that the user is calculating the slope intercept, and then they store it. Questions on calling functions? So I tried to explain this yesterday when I was thinking of like how I thought about functions, and I like to think of them as planets. These planets have two rules. Planets have two rules. They can only be visited by workers from other planets. So every planet has workers. After they work, they go home. They have to go home. They cannot stay there. So if I'm here on Earth, I go to another planet to do work, and I come back. I'm going to show you what that really, really means. Bless you. So here, Int Main is the main planet we've been working in, right? This is the planet we're most familiar with. So I put Earth. In order to do other jobs, I will go to that planet, do the job, and come back. Return. I return home. Anytime you hear go home or come home, think return. Think return. So when you see return 0 at the end of int main, that means int main, the worker in int main is returning somewhere else. We don't know what that planet is. I don't even know what it is, but it's going somewhere. But in your int main, let's say, going back to this slide, this meant I went to some planet called Foo. I got something and I came back. I went somewhere and I came back. Same with Bar. I went to a planet called Bar. I got something and I came back. I return home every time back to int main. So looking again at this example, I have 3 planets that I can visit and do work on each of them. And I do a different type of work on each planet. This planet I would go to if I wanted to get the age, and it's going to give me it as an int. This planet I go to tell if somebody has a car, and it's going to give it to me as a bool, true or false. I have my last planet, which is eat. It doesn't give me anything. I'm going to go over there, I'm going to do some work. I'm not bringing anything back. I'm just going to go over there, do something, I'm going to eat, and I'm going to come back. So let's say I'm writing a program, I'm at int main right now. I'm here. And let's say I want to get a user's age, right? What planet would I go to get the user's age? Get age. And what happens once I go there? Once I get the age, then what? Bring it back. Bring the money home. Bringing it back home. I have to come back home. I have to return. I have to return. The only time I don't return is if I have void. But I'm going to still end up coming back. I'm just not bringing anything back. I'm going back. I'm just not bringing anything back. So let's say I want to know if a user has a car. Which planet am I going to? Has car. And once I get the value of true or false, what am I doing with it? Bringing it back. Bringing it back. So let's say I want to eat. Where am I going? Void eat. And then where I eat, now what? Gotta come back. Can't bring the food, but I can come back, man. I can come back. Anytime you hear go back, come back, think return. This is what you're actually going to see in your code, return. Return means I came from somewhere else and I'm going back to where I came from. Job is done. That's what return means. Questions on this? I'm going to break it down even more, but questions on the concept of like return. You got it? So let's say I want to write that code. Let's say I want to write that in code. So boom. Look, I know I live on Int Main. I'm creating Int Main because this is where I live. So from here I can go work in wherever I want, wherever I have access to. But I always got to come back because this is the function I'm creating. So let's say the first step in this, first thing I want to do, first piece of work, the first job I have is to get the user's age. We said we're going to go to what planet? And get age. In order to make use of the fact that I went over there and brought something back, I would store it in a variable. Question.
Wait, wouldn't you put the age label first? Well, because I know that like C++ is sequential with its stuff, so like wouldn't it need to know what age are equal to before it's labeled as an int? Or
You mean like here?
yeah, where it would like go or yeah.
You saying like this is wrong?
No, I'm just confused because that's how I usually think how C++ works.
So what this is going to do is taking one step back. I know I want the user's age, and to show it in terms of the slides and the transitions, I just first create the variable. I first create the variable. It doesn't have a value yet. Remember, I can get a value from user input, or I can literally say age equals 16. I have options at this point.
Oh, okay.
I'm gonna get a value from the other planet.
Okay.
And this is telling me the planet is called get age.
Okay.
So how would I write the next line of code to go to that planet and bring me a value back and store it? Int equals get age. So it goes to this planet and it brings a value back. And we're gonna store it. Think of this as like your safe. You put the money in the safe. Without doing that, you basically lost it. So every time I go get a value, I'm bringing it back and I'm storing it.
Oh, this is just a storage?
Yeah, so this is creating a storage unit. Remember, variables are just storage units.
Yeah.
I'm going over there to get something. I'm gonna work, because to get the age, I might have to do a whole lot of work. I might gotta ask 100 people, right?
Yeah.
So I'm gonna go over there, I'm gonna do the work. I finally got what I need, now I'm gonna return home. So this returns an integer, which is why we're storing it in the integer.
Okay.
If this returned a bool, I could not store it in the integer. The type that it returns have to match the type of safe that I'm trying to use to store this thing in.
Yeah.
Question?
So that get age can also be like how you have int main and then have its own code inside of it.
Yeah, so somewhere on this planet, there's some code that has int get age and it has its own steps. Yeah, so every function that we call is created somewhere. So let's say now I want to know if this user has a car. What planet would I go to? Has car. So first, I'm going to just create my variable, get my safe ready, and I'm going to head over there. I'm going to go to the planet called has car. I'm going to go get that value of true or false, come back, put it in my safe. That's the concept of return in a nutshell. You're going to get a value, you're bringing it back.
And it's stored throughout like the whole program.
Yep.
And that's the reason
Yep. Exactly. Questions on this concept? And I got like a bunch more examples, but making sure we follow. Cool. So in this example, I'm telling you what planets I have that I can visit. 3 planets that I can visit. Soccer is fave sport, football is fave sport, and b-ball is fave sport. If I go to any of these, I'm coming back with true or false. So now I want to write the code to fit this scenario. Based on whatever their favorite sport is, I want to print out their favorite sport. So if the favorite sport is soccer, I want to print soccer. If it's football, print football. If it's basketball, print basketball. Else, let's say I print. Let's just worry about the if and the else for now, and then we can figure out what else should be. So how would I write my first if?
If, I guess, favorite sport is equal to soccer or starts with the S, and you can do that.
What planet did you go to get that? Remember, we have to visit a planet in order to get the true or false. Soccer is favorite sport. And if you read this as plain English, we get what? If soccer is favorite sport. It reads like the real question. If soccer is favorite sport, do something. Else, if football is favorite sport, do something else. Else, if b-ball is favorite sport, do something different. The way that I named them is so it reads like plain English. So this first condition will check if soccer is a favorite sport. You don't know how that gets done. All you know is you went to the planet and you coming back with the answer. You don't care how you got the answer. You just know you coming back with the answer. So soccer is favorite sport is some function that exists. Once we go, we're going to get our answer. We're going to return. We're going to come back. So if soccer is the favorite sport, what do we want to do? Oh, so yeah, we could put, good point. So we can check if soccer is favorite sport equals true, or we can just leave it as soccer is favorite sport. Yeah, C++ already knows you checking if this thing is true. Yeah, just like variables. Yeah. So I'm going to leave this here, and then the next one I'm going to leave it out, just to show us the same thing. So if soccer is the favorite sport, what do we want to do according to the... Yeah. Yeah. And so for the next case, huh? Yeah. I'm gonna just say print. And okay. And what about this last case? Well, second to last case. Yeah. And we're gonna say print. Else, if something else ended up being the favorite sport, let's say. So it's a possibility that none of these were true. It's a possibility none of them are true. So in this case, we would, let's say, print, you don't have a faith. So walking through this from top to bottom. Here we want to check, because remember we have 3 planets that we can visit. Your lab is going to be the same exact way. The TAs tell you what functions you have available. Based on how the functions are created, you want to know the possibilities for values that it can give you. Most of them is true or false. Most of the functions you're going to have available give you true or false. So for the first one, I know soccer is favorite sport. Somewhere on that planet, I can go over there and do the work and come back with the answer of whether or not soccer is the user's favorite sport. So I use that here. I say if soccer is the favorite sport, print out soccer is my favorite sport. Else, if football is my favorite sport, do the same thing for football. Else, if basketball is my favorite sport, do the same thing for basketball. If none of these were true, we're just going to say you don't have a favorite sport, even though there's like a bunch of other options. For the purpose of this, we're just going to say you don't have a favorite. Questions on this? So let's say in this case, the scenario is if a student doesn't have any more classes and the student has a ride home, they should go to their apartment. Both of these cases need to be true in order for them to go to the apartment. There's 3 planets or 3 functions that we have available. The first one, has more classes, tells us if a student has more classes. Ironically, we want to know the opposite. We want to know if they don't have more classes. So we already have this available. We can make use of this somehow. The second function we have is has a ride home. This tells us if a user has a ride home or a student. The last one, go to apartment, it doesn't give us anything, it just does something. So we're gonna go to that planet, do the work, and come back. We're not coming back with any specific value. So there's no if involved with go to apartment. Go to apartment just makes the student go to their apartment. So how would I start writing the code for this one?
If
Oh, that is already stored?
parentheses,
It has more
Has more
classes is
classes
equal
equals
to false.
So we don't need y'all right. We don't need any values because the whatever we get from when we come back from the planet is already gonna be the value of true or false. So if has more classes equals false.
and
And has right home equal true.
Then we should do what? If they don't have a
Just,
Huh?
would you just put CO go to apartment? Or
you have a function that can go to the apartment for you, which is what?
Go to apartment.
Go to apartment. Yeah, I got that one quick. So, boom. If has more classes is false, meaning they don't have any more classes, and the user has a ride home, then go to the apartment. Go to the question.
Did you use the exclamation
I
mark?
was just about to rewrite it. Yeah, yeah. I wasn't expecting y'all to do it this way, but that was a good catch. So this is definitely another way you could write it. So I'm gonna like format it.
Oh, right. You could just do it like has more classes equals true.
Yeah.
And then put the thing in front of it.
Yeah, and then you only do.
So you could do boom. Either way will work. In industry, of course, we would have something like this. So this reads as if does not have more classes. I meant to put a space right here. And has a ride home, go to apartment. This is still fine. It's just like it doesn't necessarily read as smoothly.
Yeah.
Yeah.
That's excellent.
So does go to apartment like not mean anything?
That's
No.
because it's voided.
Yeah.
Avoided.
Yeah, that's
It
Yeah.
just exists.
Yeah,
It's just
exists.
yeah. It does something, but it doesn't provide you a value.
Oh, okay.
So it's not like get age or like it's not asking a question. It's just more of an instruction, if that makes sense.
Like how we was reading it on the last
Which question? What void? Yeah. So
question.
yeah. Mhm. Yep. So your lab questions, they're not requesting any information. I mean, I guess don't think C in and C out is like are questions. They're more so instructions. So like looking at these in contrast to one another, has more classes and has ride home. These are questions you're asking somebody. Do you have more classes? Do you have a ride home? Go to apartment isn't a question, it's an instruction. So void is normally your instructions, like do this thing, but you don't need to give me a value. I'm telling you to do it.
Like go eat.
Yeah, go eat.
You're not bringing.
Yep, exactly. That's why in this example, when I presented the planets, eat was void.
Avoided.
Yep. Because it's not a question, it's an instruction. I'm telling you go do it. Has car and get age are things where I'm like requesting something back. Yep. Exactly. I'm waiting for some information. So are we good on this? Any questions on this piece? All right. That was it. So in your lab, I'ma like kinda, kinda, let's see. So yeah, there's a lot of code. I know. Now my stem don't even work. Oh, y'all's not working either.
They do it different.
Hold on, I'm about to show y'all. I'm about to give y'all like help on the lab before I like let y'all just. Oh, it's not working. Huh?
Open it in the incognito tab. Command Shift N. That works. Oh wow. Is it the Wi-Fi?
I'm on the Ethernet and all that. Oh.
It's always trash.
It's already up. Dang, that's kind of crazy. That's crazy. All right, hold up. Let's see.
Why did it work there?
I don't even know. So I'm gonna see if I can. All right, so I got it on here, right?
Yeah.
So when you see the assignment, you're gonna see a bunch of code. I know. It's like, dang, where do I start? Where you start is lab4.cpp. Just like all the previous labs, you started in lab whatever.cpp. Same here. Looking, the TAs made the first function in this file, the one that you're gonna do, so you don't have to find anything. This is where you started. So it literally says, this is where I'll need to write my code. This is where I need to write my code. And it tells you what planets you have access to. Would collide and out of bounds and move character and check for exit. I think this comment might be a little outdated. I think the actual... Yeah, so the functions that you actually have access to are here. You have access to all of these functions. So 17 through 32 in file lab4_utils are the planets that you can go visit to do work. You see these give you a bool back, which is true or false. These are void. So I'm gonna explain like, huh? Yeah, exactly. So I'm about to explain the concept behind the whole lab, and I'm gonna tell you where these become relevant. So make sure you get in this. I really don't want to have to explain it a second time. Can you make sure bro paying attention, because he's gonna be the main one. Yeah, I'm explaining. I have, how many is this? 13 functions I have access to. 13 functions I have access to. Hey, Brian, you wanna wake bro up? Cause I'm literally not gonna explain this again. I'm not gonna explain this again. I have 13 functions I have access to. In lab4_utils, this is where you're gonna see all of them. The first four, remember, think of these as planets, places I can go to get answers and do work, and I'm gonna come back with something. If they tell me that I can come back with something. So the first four I have would collide up. This will tell me if I go up, if I would hit a wall. The next one tells me if I go down, if I would hit a wall. These are true or false questions, right? If I say would collide up, I'm expecting a true or false in return. That's what these do. If it tells me if I go in any of these directions, would I hit a wall? The next four, move character up. These are just like your instructions, right? Just like eat or go to apartment. If I call any of these, this just moves my player in the specified direction, up, down, left, or right. The last four, out of bounds up. This is similar to would collide, the would collide functions. This tells me if I go out of bounds, if I walk in any direction. So the concept is, if I won't collide in that direction and I won't go out of bounds in that direction, it's safe to move in that direction. That's the concept. That is the concept. And so basically after you move, the lab is telling you need to check for exit. So after you move in any direction, check for a way out. All you do is call this. Again, this is void, so we're not expecting anything in return. It's an instruction. So the way you can think about it, and this is kind of one of the answers, if I won't collide up and I won't go out of bounds up, move up. Once I've moved up, check for an exit. Check for an exit. And so to even give you more hints, I'm going to show you how I would start it. So I would go to the function where it says start writing your code. I would leave the comment there. I would just start a new line, start trying to type, right? I'm going to think. But I think the functions that were given are a little updated in the comment. But I would still leave it. Just remember all your functions are here in Lab 4 utils. So I'm going to say, boom, look at how this function is void, but it takes a character which is representing a direction. So if the user presses up, that means the user is trying to move up. We need to see if it's safe to move up. Remember, we have our checks right here. Would collide up and out of bounds up. Will tell us if both of those are true, we know it's safe to move up, right? If one of them is not true, we can't move up. Because that means we're either going to go out of bounds or we're going to collide with a wall. So both conditions have to be true in order for me to move up.
So like basically, so it's like if they want to like move up, you like check to see if it would collide, and then if it doesn't, then they move up.
Well, you got another check you need to do. But colliding is not the only thing that could go wrong.
Oh, bounds.
Out of bounds.
Okay.
So basically what this function is going to happen anytime a user presses up, down, left, or right on the keyboard. I'm going to start y'all off with how you know which key was pressed. The way you know that is this function gets called and it's going to automatically give U, L, D, or R, up, down, left, or right. That's going to be as a char. So I would say if direction equals up. That's all I need. This tells me if a user entered up or pressed the up key. Inside of here is where I would handle all this stuff for up. I would need more if statements for the other directions. Remember, you got 4 directions. For each direction, you have a chance of colliding or whatever the other case was. You can either collide or go out of bounds. If neither one of those things happen, you're safe to move in that direction. Once you move in that direction, you need to check for an exit. Question?
Basically, we're making a bunch of if statements.
Essentially, yeah.
A whole bunch of them too.
Who said that?
A whole bunch of them, right?
Depending on how efficiently you can write your code. I did the lab. It was probably like 10 lines.
Like that?
Yeah, when I did it was like 10 lines total.
What is the, so how do, we're moving, how do we know if we hit a wall? Like, where's the board that we see?
If you want to see it, I didn't like run it. If you run it, that's when you'll see the actual board. I just read the prompt and solved it that way. Huh?
Wait, what do you mean?
What he's saying is
Basically just typing out the code and the rest of the code is already
wake your ass up, Pete.
in the script.
Check it if it returns to either one should work. I would probably use this.
Oh God, we are. Oh man.
This.